Okay, this is a summary of Chapter 2 from Math 2101. So if you're not studying that book, hopefully this is useful to you. If you are studying that book, when you read Chapter 2, if you don't understand afterwards the things that I'm about to show you, it means you need more time with Chapter 2. We have a situation where a family of 4 people are going on a vacation and they're trying to decide exactly which vacation to do. They have a budget of $6,500. There are 2 parents, a 10-year-old daughter and a 2-year-old son. They are looking at certain expenses that have to fit within that budget. They're looking at renting a villa on a Caribbean island, and the first villa that they're interested in, it costs $1,200 per week. The second villa costs only $850 per week. An adult airfare is $1,000, but a child under 3 costs $300. The taxi between the airport and the villa costs $40. And they also have decided they have to buy a new set of luggage, which costs $350. We're going to make an expression, which could also be an equation, to decide which vacation they will choose. We want to know which villa, and we want to know how many weeks. Now, the answer is flexible. If you are this family, you aren't necessarily choosing the cheapest option. You might say, well, this option costs more, but it involves having an extra week, so that's my choice. Or you might say, this option costs more, but it has a more luxurious villa, and I might choose that. The first thing that we're going to do as we make our expression is we have to define some variables. So I'm going to call V sub 1 the rental cost for villa 1 per week. That's the $1,200. V sub 2 is the rental cost for villa 2. A is the adult airfare. And C is the child airfare. That's the child under 3 years old. T is the taxi cost. So now we can build our expression, but we have to use some numerical coefficients. We're going to start by calculating 2 weeks in the more expensive villa. So what that means is, I'm going to start with the airfare. There are 3 adult airfares because the 10-year-old pays the adult airfare. So we're going to write 3A. We're using a numerical coefficient and placing it to the left of our variable for airfare because we have to pay that airfare 3 times. Plus, we're only paying the child airfare once, so we just write plus C. We also have to pay the rent for villa 1, and we're considering 2 weeks, so we're writing plus 2 V sub 1, 2 times the cost per week for villa 1. We also need the taxi. Watch out. You take the taxi to the villa from the airport, but at the end you have to take the taxi again back to the airport from the villa. So it's going to be plus 2T. And the luggage set, I'm doing something interesting with the luggage set. I'm deciding that they're buying the same luggage set regardless of which vacation they choose. So we're going to treat the luggage set as a constant term. We're writing plus 350. Now this is an expression. It doesn't become an equation unless I put an equal sign. And I'm going to decide whether I want to do that. Because I'm not trying to make this vacation cost exactly $6,500, so I don't really want an equal sign. What I want is for it to be less than $6,500. So I put a less than sign. A lot of students will think, no, they'd rather not have to do this. So they have choices. One thing you can do is put an equals there instead, but then you have to do this extra step at the end where you realize we don't have to have an exactly equal amount. We have to have an amount that's less than $6,500. So you're just doing the step at a different stage in the process. Another thing is to just treat it as an expression, find the total cost, and then worry about the budget afterwards. Let's try doing this. We're going to replace our variables with the values that go with them. So it's 3 times $1,000 plus $300 plus 2 times 1,200, that's Villa 1's cost, plus 2 times the taxi of 40 plus 350. And we can get our total. Simplifying, I have 3,000, 2,480. After I apply my numerical coefficient, multiply it by its variable. And then when we add these together, 54, 57, 106, it's 6,130. Is that less than 6,500? Yes, we can do this vacation. But let's try it again with villa number 2. It changes the equation a little bit because we still have the 3a, the c, but it's 2 times v sub 2 this time because we're using a different variable because it's a different villa. Plus 2t plus 350. So most of it doesn't change. We have 3 times 1,000 plus 300 plus 2 times 850 plus 2 times 40 plus 350. That gives us 3,000 plus 300 plus 1,700 plus 80 plus 350. And to save room, I'll write the answer here. This ends up being $5,430. So I checked that off as well because that also fits underneath our budget of $6,500, but it makes me have an idea. Wait, let's do this again, but we'll consider 3 weeks with villa number 2. It's pretty obvious that we're not going to be able to afford another $1,200 week with villa number 1 here, but maybe we can get an extra week out of our vacation this way. So it's 3a plus c, but now I'm writing plus 3v sub 2. 3 weeks times the cost of villa 2 per week, plus 2t plus 350. Again, not very much changes. 3 times 1,000 plus 300 plus 3 times 850 plus 2 times 40 plus 350. 3,000 plus 300 plus 2,550 plus 80 plus 350, and I get a total of $6,280. It still falls within our budget, so my choice is I'm taking villa number 2 for 3 weeks because I want that extra week. And that is a correct answer. But another student's choice could be, I'm sticking with villa number 1 for 2 weeks because I want the more luxurious villa. A third student could say, I'm taking villa number 2, but I'm only going for 2 weeks because I want to spend only $5,430 and save a little over $1,000 for next year's vacation. All of these are correct answers so long as you do the calculations and justify what you're saying, what your choice is. Now we're going to move on to a different type of calculation. So I'm going to erase all the information about the villas, the vacation trip, and my answer. Seems sad after doing all this work to erase all of that, but on the other hand, it's being videotaped. So it's not gone forever. I can just look at the video and I can see all of it over again. What we're going to work on now is isolating a variable. And the formula we're going to use is the classic distance, speed, time formula. So I'll just write that, distance, speed, time. I'm writing 3 versions of this formula. S equals d over t, that means speed is equal to distance divided by time. T equals d over s, and also d equals st. Now, why would you have three versions of this formula? Because there are three variables in the formula, and we can do algebra to move the variables around so that we can choose which letter we want isolated on the left of the equal sign. And there are reasons to do that. We have to define what our variables mean when we do something like this, so I'm going to do that up here. D equals distance, S equals speed, T equals time. Now, why do I say they're really the same formula? Because I can take one of them and do algebra and turn it into one of the others. So I'm going to prove that. S equals D over T. If I want to get rid of this T that's in the denominator, I'm dividing by a T. So I can do the opposite. Algebra allows me to multiply by a T. These will cancel, that's good, but wait, algebra says I have to multiply both sides by a T. Then I'm keeping the equation the same by doing the same thing to both sides. These cancel, and I have TS or ST, whichever way I want to write it, equals D. But I now have two letters on the left side. I'm going to keep the T on the left side. I'm going to try and make this happen. So what I'll do is, since the T is being multiplied by an S and I want to get rid of the S, I do the opposite of multiplication, which is division. I divide both sides by an S. These cancel. My T is now isolated and it's equal to D over S. Same thing we have here. So that sort of shows that this formula and this formula are really the same formula. Let's do some other tricks. T equals D over S. So we're starting with this or this, whichever you want. And I want to turn it into D equals ST. Well, one trick I can do, and I talked about this in the chapter 1 review, is I can turn this backwards. Any equation can be written forwards, backwards whenever you want, because what's on one side has to be equal to what's on the other side. That's the whole point of an equation. The two sides are equal. So T equals D over S means the same thing as D over S equals T. So I've done some of my work. I got the D on the left side, but I want it alone, and it has an S. It's being divided by an S. So I'm going to multiply both sides by an S, the opposite of division. These cancel. D is now isolated and is equal to ST, or TS if I prefer. I've got this one. So all three formulas are the same. Next thing to do with these is try using them. Now, let's make a situation happen. I'm going 200 kilometers. That's a distance. I'm going 50 kilometers per hour. What amount of time is it going to take? So this is a classic question that allows the student to use one of these formulas to answer it. And let's answer this question more than once and play around with these three formulas that are really the same formula. The most intuitive thing to do is to say, since I'm looking for the T, I want to use this version of the formula because it already has the T isolated on the left, and that is more convenient very often. So I keep the T as a T because I don't know it, and I replace the D with the 200 and the S with the 50, and now I have a quick simplification to do. T equals 200 divided by 50, which is 4. It has to be hours because the speed was given in kilometers per hour. So it will take me 4 hours to do this trip. I've answered the question. It was most convenient to have the T isolated on the left to do that. It's always most convenient if the letter you're looking for is the one isolated on the left, but it's not the only way to do it. Let's try answering the same question with this version of the formula. We have S is 50, D is 200, and T is still T, because we don't know it, we're trying to find it. We're in an algebra situation, and it's a weird one, because we have a variable in the denominator. What do you do when your variable's in the denominator? Well, what I do is I call it the trade. I'm allowed to trade the 50 and the T. I'm allowed to trade the thing that's alone on one side of the equals with the denominator on the other side. Now that I've done the trade, it's a quick simplification, and I have the same answer that I had before. In fact, the final calculation was the same. So why does the trade work? Let's look at that. The trade works because of algebra. So let's try this again, but we'll show more steps. We have 50 equals 200 over t. We want the t on the left alone. But it's on the bottom. What do we do? Well, when you're dividing a 200 by a t and you don't want the t there, you do the opposite of division. You multiply by a t, which will allow us to cancel, but you have to multiply both sides by a t. These cancel, and I have now 50t equals 200. My t is on the left. That's good, but it's not isolated. It has a 50 with it. The 50 is being multiplied by it, so I do the opposite. I divide by 50. These cancel. T is equal to 4, and I have my answer again. So I just did the same thing that I did here, but I showed more steps. So whether you want to do the shortcut, which is the trade, or show all the steps, either way you can get to the right answer. And what we have shown is when our unknown is a variable in the denominator, that doesn't have to stop us. We can still solve. What it also shows is yet more proof that these are really all the same formula. Let's try doing this version of the formula with the same question. I'll erase these. Haven't used this one much. So I'll write it here. D equals ST. D is 200. S is 50. Oh, I have 200 equals 50t. I want my t isolated. I might like to have it isolated on the left, but I know the left side equals the right side, so it doesn't matter if the t is isolated on the left or on the right. So I'm just going to get rid of the 50. The t is being multiplied by a 50, so I divide both sides by 50. Cancel, cancel. T is isolated. 200 divided by 50 is 4. I still have t equals 4 hours, but I set it backwards. It's 4 hours equals t, which means the same thing as t equals 4 hours because left side equals right side. That's the whole point of an equation. So we could do this. We could use any of these formulas to answer this one question. There's all sorts of fun things we can do, and what we can do is we can show the formula the way we prefer. So a student might have a favorite way of doing this. Maybe the student should do it their favorite way because that's the way they're most likely to feel comfortable. They feel less confused when they're trying to answer a question. They're less likely to make a mistake. Now let's look at gas consumption. The gas consumption situation can also be expressed with a little formula. And it's really not very different from the one we were just working with. Consumption, I'll say C equals consumption. Consumption is equal to V over D. V is equal to volume, and D is equal to distance. Gas consumption when you're driving a car somewhere, or if you're driving another motorized vehicle, it will still be able to be calculated with this little formula. C equals V over D. Now I have seen this, including in my textbook, where V is Q. It means the same thing. Q just stands for quantity, quantity of fuel, where I'm choosing to use V for volume of fuel. Since I define the variables, I can do this way if I want. The two approaches are equivalent. So consumption equals volume divided by distance. Let's do an example. We're going 500 kilometers. We used 40 liters to do it. What is the gas consumption? Okay, so we're plugging in. It's very similar to the distance, speed, time formula. C is unknown and it's on the left, so that's convenient. V is the volume, that's the 40. Distance is 500 kilometers, so I have 40 divided by 500. I simplify that. And I get 0.08. What's my unit of measure? This was always liters, and this was always kilometers. So it's 0.08 liters per kilometer. Well, 0.808 is a small number. It's a very small volume of gas that carries me a kilometer in whatever vehicle it is I'm driving. But there's a standard way of expressing gas consumption. We choose not to use liters per kilometer, partly because it tends to give these small decimals. Instead, we choose liters per 100 kilometers. So the unit of measure looks like this for consumption. And all I'm doing is I'm multiplying this by 100. It means the consumption is going to be 8. 0.08 times 100 is 8 liters per 100 kilometers. So it takes 8 liters of gas in my tank to cover 100 kilometers. Since we probably don't drive a motorized vehicle distances like 1 kilometer very often, we have a tendency to use motorized vehicles when we have to travel a further distance. 100 kilometers is a little bit normal sounding for a distance you would drive. So you can see why this might be chosen as the standard instead of this. 100 kilometers is easy to visualize when you're planning a trip, and the fact that I multiplied by 100 means I'm less likely to get a small decimal as my consumption. I end up with a number that's maybe a little easier to look at and work with. So that's the consumption, the gas consumption formula. In this book, 2101, there can be a lot of situations where the student is expected to apply this, but it always really works the same way. So if you get used to doing a few examples with it, you should feel comfortable enough so that you could, for instance, if calculating the cost for a family vacation, I guess the family usually doesn't calculate the cost of jet fuel. So let's say it's a family vacation you do in a car. You would be able to do this to figure out, if you're given enough information about the vehicle, the distance, the volume of gas, or the consumption, you can be given some of those and find out the others, and then you would be able to incorporate that into your calculations for instance, how much is it going to cost to do a trip? If you know gas costs $1.20 a liter right now, then, well, I need 8 liters to go 100 kilometers. 8 times $1.20 is $9.60. It would cost me $9.60 to do a 100-kilometer trip. That helps when you're calculating the cost of a vacation. So that's the type of scenario where you might have to use this. We're going to only cover one more concept in this chapter review. We've seen a lot of very simple equations that we solve with algebra. And we've gotten used to this idea of moving things left and right across the equal sign. When you have addition, subtraction, and you move things across the equal sign, they tend to change sign. When you do multiplication and division, they don't. We're getting used to this. But we're dealing with very small equations, like 10 equals x plus 3. I move the 3 to the other side, it becomes negative. I'm doing the shortcut here, x equals 7. I get to my answer very quickly. But what if there are more things than just these? In a math question, you can be asked to deal with things that are a little longer. How about 2p plus 3 plus 5p equals 3p minus 7 plus 6. Now I can start combining my p terms right away over here, and I can start combining my constant terms right away over here, but I'm not going to, because I have a mixture on both sides. So there's a choice happening here. I'm deciding not to combine similar terms right away. And remember, you cannot combine terms that are not similar. We cannot say 2 plus 3 plus 5 is 10. That won't work. 2p plus 5p is 7p works, and then we just have to write plus 3 with it if we're combining similar terms. What I'm going to do is I'm going to use some of the shortcuts to move this 3p to the other side of the equals. So the only thing that moved was the 3p. It was positive, it moved to the other side, it's being added to this side. So when it's moved to the other side, that's subtraction on the other side, it changes sign. We're expecting that to happen. Watch out for this. We had a term before this minus. When we get rid of that term, the minus is still there. You can't just write 7 plus 6. You're making your equation wrong. You're making it different. The 7 is negative, and it didn't have to change signs because it did not change sides. So we now have all the p terms on the left, but we don't have all the constant terms on the right yet, so I'm going to do another step. I'm keeping all the p terms the way they are, and I'm moving this 3 to the other side, where it becomes negative. The 3 is being added on the left side, so when I move it to the right side, it becomes negative. It's subtracted. Now we can combine similar terms. I have nothing but p terms here and nothing but constant terms there. 2 plus 5 is 7 minus 3 is 4p. Negative 7 plus 6 is negative 1 minus 3 is negative 4. I have a much simpler expression now, much simpler equation. If I divide both sides by 4 to isolate my variable on the left, I have p equals negative 1. I have an answer. There are other ways of showing the steps, but make sure you show your steps. Let's do one more example. Not very much different about this example, except what about when you have terms that are identical? Okay, so I have 6a plus 19 equals negative 6a minus 5. Okay, this time I'm going to show all the steps because it's a little shorter an equation, so it won't take as long. I'm going to keep the 6a and the plus 19. I have a minus 6a here, and I'm going to do the opposite. I'm going to add a 6a so that I can get them to cancel, which means I have to add 6a on the other side. I'm adding 6a's to both sides. I'm not using the shortcut. These cancel though, and I have 6a plus 19 plus 6a equals negative 5. Remember, that minus sign's still there. I want to move the 19 to the other side now. So 6a plus 19 minus 19 plus 6a equals negative 5 minus 19. I'm subtracting a 19 from both sides, and I'm showing all of the steps. These cancel. I have 6a plus 6a, which are two identical terms, equals negative 5 minus 19, which is negative 24. I've combined my similar terms on the right side. 6a plus 6a is 12a. Now I've combined similar terms on the left side as well. I don't want that 12 there, so I divide both sides by a 12. Opposite of multiplying by a 12 is dividing by a 12. Do it on both sides, and you're good. Cancel, cancel. A equals negative 2. I have an answer. So the only thing that was different between this and the previous example, besides the fact that I showed more steps, is we had two identical terms, but so we were going to combine similar terms even if they had not been identical. They both have the same variable, so they're similar. So they can be combined. 6a plus 6a is 12a, just like 6 plus 6 is equal to 12. That is a review of Chapter 2 from Math 2101. Hopefully it helps you.